Guys, today we're going to talk about graphing proportional relationships, and the I can statement we're working on is I can determine if two quantities are proportional from a graph, and I can identify if the constant of identify the constant of proportionality from a graph. So very similar to our last set of quadrants. Again, we have two I can statements, but they're going to go together. So in order to go through this video, we're going to skip right now to the companion guide to help us determine how can I look at a graph and determine if relationships are proportional or not. So make sure you've got that out. You're also going to want to have your composition book open to your WSQ because there's parts that you're going to want to put from the companion into your composition book as well. So let's get that out. Okay, here we go. So I'm looking at my companion worksheet and it says determine whether each relationship is proportional by graphing on a coordinate plane and explain your reasoning. So you're going to need to go ahead and draw just the first quadrant on in your composition books when we get to that. Before we get into the graph portion, let's review what we already know about proportional relationships, looking at number one. Before I graph it, I can tell from the table if it is or is not proportional. So let's look at this. So here we go. Remember, I'm going to ignore those zeros. Now, this is going to come into play today. We're going to talk about the zeros and how that helps us determine if a relationship is proportional or not. But let's start with here. Remember, time is always going to be our independent variable. Y distance then makes distance our dependent variable. So COP, remember, is Y over X. So here we go. 45 over 1 is 45, which is equal to 90 divided by 2 is 45. So far we're good. 135 divided by 3 is 45. So far so good. And 180 divided by 4 is also going to be 45. And if you want to double check my math, you can go ahead and do that. So what we can determine here is that, yes, this is proportional, and that the COP is, because when I divide y by x in every case, I get 45. That's my COP. Okay, so we know this is going to be proportional. So when we go to graph it, knowing that it's proportional is going to help us when we make some observations about whether, how can we tell from a graph if we have a proportional relationship. So now I'm going to go ahead and I'm going to graph these on a coordinate plane. Looking at my x's, I need to go at least to 4. Looking at my y's, I need to go at least to 180. When I created my graph, I used a scale. Now, when you're given a graph, you don't want to just put all of your numbers right in here and have your little graph in this corner in this big empty blank space. So you're going to want to use a scale to space it out because I'm going to want to fill my space as much as possible. I chose to go by 15s. It puts me a little short of the top, but this is okay. This is pretty close to the top. Now, when I went and did so these are my y values, and when I went and did my x values, I spaced it out to 5, skipping 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So a couple things to note when you're making a graph. Using a scale, the scales on the x and y axis do not need to be the same. But another thing you can do is space out your values on an axis. So you can either use a scale to space it out, or you can physically space it out. I've got a title. I've labeled my x and y axis with what those values represent. So now let's get to graphing it. In a table, don't forget, when I make my coordinate pairs, it's always x then y. So here I'm going to have 0, 0, 145, 290, 3, 135, and 4, 180. Okay, so those are my values. I'm going to graph them. 0, 0, 145, 290, 3, 135, 4, 180, okay? And after I've graphed this, you might have noticed, some observations. I can connect all of these points here, and they form a straight line. Maybe that is what makes it a proportional relationship on a graph. Remember, we didn't talk about zero yet. Notice where zero is on this graph. It's at the origin. Okay, so that's something to think about. What I want you to do now is go ahead and pause the video, and I want you to create the graphs for numbers 2 and 3. Then press play, and we will talk about whether or not these are proportional relationships and make some more observations. Okay, let's check your graphs. So for number 2, we have ticket prices here. I'll notice when I connect them, I get a little bit of a curve. Maybe it crosses through the origin, maybe it doesn't, not really sure. So 0 could be 0, 0, it could be 0, $5. I'm not sure. We can assume that if you're getting no tickets, you're paying no money. So that we could assume that 0, 0 would be a spot that we'd cross through. Notice in number 1, we had a straight line. I could tell that if I kept going on forever and ever, I could predict the prices. Here, I really didn't draw an arrow because I'm not sure exactly, is it going to go on in that way? Is it going to shoot up this way? Is it going to end up coming down? I don't know. So I stopped there. With number 3, I noticed again I've got a straight line. If I continued it down, it would definitely go through 0, 0. I can go ahead, even though my graph stopped here, I could even draw an arrow here because I know that the cost of the chicken dinners is going to go up by $12 every time. So I've got a straight line. Now, let's go back to what we have here and let's check our work. So we decided number 1, yes, that was a proportional relationship at a COP of 45. Looking at my graph, I'm going to put this one off to the side because it's a yes. Now let's look at number 2 and determine if that's proportional. I'm going to see that it's not proportional because when I take my y divided by x, 100 divided by 4 is 25, 190 divided by 8 is going to be 23.75. So right away I know it's not proportional. There's no COP, but I'm not going to explain yet because I have to explain why from the graph it is or is not proportional. Let's look at number 3 now. If I take my y's and divide them by my x's, 12 divided by 2 is 6, 24 divided by 4 is 6, 36 divided by 6 is 6, 48 divided by 8 is 6, and 60 divided by 10 is 6. So yes, this is proportional. So I can write proportional. And so I have 2 graphs now that I can look at and compare. Look back at 1 and 2. What do they have in common, or 1 and 3? What do those 2 graphs have in common that number 2 does not have? Well, right away you're going to notice 2 things. 1, they're both straight lines, whereas number 2, kind of curve. Not proportional, it's got a curve. Proportional, these guys have straight lines. Another thing you're going to notice is talking about 0 here. It's crossing through the origin in both cases. Here we thought maybe it's crossing through the origin, but because of the pattern, we can't really tell for sure if it does or doesn't. Because there are 2 things that need to be true for a proportional relationship when it's graphed. 1, they have straight lines. 2, they cross the origin. So let's go back to our explanations here. Number 1, yes, the COP is 45. It is proportional because it is a straight line that passes through the origin. Okay? Number 2, you're going to say it's not proportional because it is not a straight line. We don't know about the origin, so we're not going to say anything about it for number 2 because we're really not sure if it's going to cross the origin or not. Number 3 is proportional because it is a straight line that passes through the origin. Okay, oops, I forgot the R. Okay, so now let's look at number 4 together real quick. This is another one of those problems where a lot of students will get it wrong because they're not answering every question. So I want to work through this one together and then we'll be done with this video. The number of lifeguards on duty at a local swim club is proportional to the number of swimmers. So we know this is a proportional relationship. This graph shows the relationship of swimmers to lifeguards. Now the instructions say find and interpret the constant of proportionality. So there's 2 things you need to do. So COP, I can tell by looking at any 2 points on this graph. Here I've got a point 25.1. Here I've got the point 75.3. So let's make a table, an XY table. When X is 25, Y is 1. When X is 75, Y is 3. So my COP is, let's see, 1 divided by 25. Well, that's simplified. 1/25. I know it's proportional, so I know that's going to be my COP, but let's check it anyway. 3 over 75. When I simplify, divide both by 3, I get 1 over 25. So my COP is 1 over 25. It's okay that it's a fraction, okay? Now, so I've answered number 1. I have found the constant of proportionality. Now I need to interpret it. What does that 1 represent? What does that 25 represent? So when I go to interpret it, I will say, for every 25 swimmers, there is 1 lifeguard. That is all you need to do. Tell me what that ratio represents. Give me the units for that ratio. For every 25 swimmers, there's 1 lifeguard. You could have said for every 1 lifeguard, there's 25 swimmers, and that would be fine as well. Okay, so let's review what we've discussed here. Okay, real quick, just to summarize, when I'm graphing a proportion, when I'm looking at a graph of a proportional relationship, you will always get a straight line and your graph will pass through the origin, which is 0, 0. Okay. If I wanted to find the constant of proportionality on a graph, I'm still going to look at y divided by x. I'm going to divide all of my y coordinates by all of my x coordinates. Okay, we are done with this video. You can go back and watch any portion as many times as you want, but don't forget to WSQ in your notes. Have a good day.